colors, I think that would be a very good thing for you to do.
Something's off. It's not the same.
Okay.
Let's see.
All right, so a lot of vocabulary coming at you in the next 10 minutes or so, but be patient. What's up, Jen?
I was gonna ask to go back to the focus number.
That, don't worry about that number. It was just about the quizzes and the reassessments, the way they do it. Okay, so just like there once was a time where I used to say the word derivative and that automatically translated in your head into it meant something. Derivative means something, right? What does derivative mean? It means f prime, but it means something. It means something on a deep, 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 deep level. David, what does it mean? That's a notation, but it means something. Derivative means, oh my God, without the yawn maybe?
Oh, slow.
Derivative means slope, close, not good enough. Close, not good enough. Abraham? One more time. Derivative means slope of a tangent line. There was a day where we spent on that and we built our way up and all was good. Same thing today. New idea. This new idea is the definite integral. This notation right here that just looks like squiggly s from a to b f of x and a dx just means this. It represents the area bounded, trapped, like some of you feel, bounded by four things. Bounded by the x-axis, the graph of f of x, the line x equals a, and the line x equals b. That symbol, which we're going to call the definite integral, just means area. That's all. You guys have been studying area for a very, very long time. I know you guys know a whole lot of area formulas. Like, for example, if I was talking about a rectangle, you guys would all tell me length times width. Maybe you'd refer to it as base times height, right? You started studying area in elementary school. What other area formulas do we know? I'll take anything from anybody. Adriana, what else you know?
The area of a triangle is 1/2 times base times.
Area of a triangle is a half base times height. What other area formulas are out there? Eunice, give me another one.
The circle times square.
Area of a circle is pi times r squared. I bet there are some more area formulas out there. Give me another one.
The square is 4s.
The area of a square is not 4s. But thank you for trying. It's s squared. I can see why it would be hard to remember the area of a square is s squared. There's another one. Not a cylinder. Cylinders are three-dimensional. Not a cone. Cones are three-dimensional. Area of this guy here. Not a parallelogram. Trapezoid. Trapezoid. Base 1 plus base 2. The whole thing times the height divided by 2 or times a half. In order to be a trapezoid, you need two sides to be parallel. Those are the guys that we're going to call the bases. You have studied area since like 3rd grade. And then you did more in middle school. And then you took a whole course called geometry. You are masters of area. So now all we're going to do is we're going to do calculus now with area. So let's look at this guy over here. Take a moment. I want you to shade in the area that is bounded by the x-axis, the graph of f of x, the vertical lines x equals a, and the vertical lines x equals b. Go shade in that area for me. I want to make sure we're all having the same conversation. And you're getting a little too overzealous here, and he's shading in way too much. So is Abraham. This is area that is trapped. It is bounded by 4 things. The x-axis is one of your bounds. Your function is another bound, x equals a and x equals b. So if all goes well, that's the area that we're looking for. Everybody okay? So what's going to be so hard about finding this area? It's not a fixed shape, it's not a rectangle, it's not a triangle, it's not a trapezoid, it's not a circle. It's not any of the shapes with names. The good news is, with calculus, we don't need to worry about shapes with names because we have techniques, we have skills. I'm excited, and this is where we're going to focus on. All right, so let's look at this guy a little bit more. Okay, I need to reorganize the notes here someday. Okay, this guy here, here's how we're going to read it. We're going to call this the definite integral. The definite integral of f of x from x equals a to x equals b with respect to x. The definite integral of f of x from x equals a to x equals b with respect to x. And what I mean by this is not like how gangsters say, respect. I mean the definite integral, and we're going to treat x like it's the variable. So that's how you're going to read it. And what it means is, definite integral just means, oh, so awkward. Definite integral means the area, the bounded area trapped by x-axis, the curve, x equals a and x equals b. Okay, let me give you a little bit of vocabulary. This whole thing together is what we're going to call the definite integral. Here come the different pieces, though. Okay. Going from x equals a to x equals b. This symbol over here, which is my favorite math symbol, is called the integral sign. The x equals a is called your lower limit of integration. X equals b is your upper limit of integration. The f of x and the dx together are called the integrand, I-N-T-E-G-R-A-N-D. And the dx is your variable of integration. Okay. I need to take attendance real quick. Why don't you take 1 minute, go over the vocab. Check it with somebody else. Go over the vocab, go over the meaning, make sure you can read this correctly.
What is it? The limit what? The limit of integration? Lower limit of upper limit. I was playing. She is on fun.
Is the interval time, I mean sign, just an expert?
Okay. All right, folks, questions about anything we've done so far? I know it's been heavy with the notes and vocab, and we're going to start to do some actual math. Everybody's good? Okay. All right, so 2 things that you need to know. Note number 1, and this is different from anything you've ever seen before. Area below the x-axis is negative. If you are ever doing a computation and you've got area below the x-axis, it has to be negative. And I can only think of one time where you guys would have seen this before. There is one time in your lives that you know that area below the x-axis is negative.
Isn't it in the distance graph?
Right, back in physics when you guys were looking at velocity graphs and displacement and all those things, if your velocity graph went below the x-axis, you counted that as negative area. But in geometry, area was always positive. We live in a world where area below the x-axis is going to count as negative. One last thing that you need to know before you get a little bit of time to play here. What's the difference?
One A is on the top and one B is on the bottom.
It's
The
going
upper limit of integration and the lower.
Right, I'm switching these limits of integration. In both cases, the function is f of x. In both cases, with respect to x. In this case, I'm going from a vertical line at x equals a to a vertical line at x equals b. In this case, I'm saying I'm going from x equals b over the x equals a. Technically the same area. Right, if we're looking at this graph over here, I'm saying what's the area if I go from a to b compared to what's the area if I go from b to a?
It's the same.
It looks the same, it feels the same in calculus. These guys are equal, but opposite. Direction matters. If I'm going from A to B and my region is above the x-axis, I'm going to say it's positive area. But if I'm going to go from B to A, now I've got negative area.
Wait, so B to A is negative, but A to B is positive.
For this graph,
Oh, for that. Oh, that's
A to B, because the area is above the x-axis, A to B would be a positive area, but from B to A is a negative area. Rambeer, what's up?
So when you're reading this integral sign,
Yep.
you look at the bottom. You look at the bottom part of the S and the S-shaped looking thing.
The bottom part of the integral sign, yes,
Yeah.
is where you start. The top part of the integral sign is where you end. Even if A is bigger than B, A is where you start, B is where you end. Noemi, you had a question.
So for that graph, we're using the second one, that's negative?
For this graph, if I asked you to go from B to A, would that be negative or positive? Like from B to A, that would have to be a negative area because you're going in the wrong direction.
So it depends on what it is.
It's going to depend on the graph.
Okay.
Okay? All right, so slightly bad placement here. I've got a function, this is f of x. You're going to use f of x for the next 15 minutes or so to practice with. But if you flip over to part A, part A, I'm asking you,
Explain these.
first of all, to explain the meaning. Christian, can you make sure I don't erase that stuff over there no matter what? Okay, part A, I want that guy right there. First of all, explain that notation to somebody new.
It's negative. Zero.
No, it's positive.
Because 0 to 3, starting with the start with the lower limit. Start with the lower limit.
All right, my friend Martier. What am I asking you to find here?
Area.
I want the area. I want the area from 0 to 3. A relatively easy question. What's your strategy? Jose, what's your strategy here? How are you going to find this area?
We're gonna shade it in.
Okay, well, if you want to shade it in, that's fine. Feel free to shade it in. That doesn't actually like magically get you the area. But if I want to find this area, what's your strategy? What's the strategy?
Make shapes.
You want to make some shapes. Right, is this a shape that you know the name of?
No.
No, it's not a shape that you know the area formula for, but David, I think you've got some good strategies from geometry, right? David, what could you do? What did you learn in geometry? Eunice, help him out. What could you do?
You can make two triangles and one.
Okay, so it sounds like you said 2 triangles and a rectangle? Right? Do we know how to find the area of a triangle?
Yeah.
Sure. Triangle, triangle, and a rectangle. Great. That is a way to go about doing this. A way. Other ways. What are some other options? Nobody sees any other ways to split this up? Martyr, what else could you do? Do you see a trapezoid? Where do you see a trapezoid?
Oh, yeah.
Right there.
Where you had one and three?
Wait.
So I see your hand doing that. So we're going like this way?
Yeah, right.
And then this piece here is a trapezoid, and then you've got a triangle. Go find the area. Use whatever method works best for you. It doesn't matter to me. I'm going to go with the trapezoid and the triangle way. If I'm going to find the area of a trapezoid, the bases are the sides that are parallel to each other. These guys are parallel. So find the length of that base, 4. Length of that base there is 1. The height, I think the height is 4. And I'm going to cut it in half. Not 8. Plus this area over here is a half times the base times the height. Is that 4? 4 plus 1 is 5 times 4 is 20. Cut that in half, I get 10. Half times 1 times 4 is 2.
It's gonna be like 10, right? Oh.
I've got 12. Did I do something wrong?
Oh, I mean the area. Isn't it the area of the trapezoid?
Area of the trapezoid. That, oh no, that's not 4, is it? That was my mistake. That's 3. Okay. Sorry about that. 3 plus 1 is 4 times 4 is 16. Cut that in half is 8. So we've got 8 plus 2 is 10. How many guys came up with 10? These should be relatively straightforward, although the notation is new. The idea is new, the vocab's new. You trust your geometry skills. I want to give you guys the next 10 minutes to play around with these. The goal is to complete parts B through, is it F or G? B through F.
Wait, so are there, it's just, the answer's just 10, like there's no
Well, because the question,
units or anything?
right, the answer is 10 because the question is how much area is bounded by the function from x equals 0 to x equals 3 in the x-axis. Okay? Whoever is the oldest at the table is in charge of the cups.
Oh, that's 4. 1.16. Okay. Oh, we're doing 8. I'm waiting for it to get more complicated.
Why did you change the A and B then?
Because this is not
What's
going
the
to be
negative? No, negative.
two trapezoids, right?
That's what we just saw right now. Okay, okay.
I'm waiting for it to get
I believe you.
No. It's from 1 to this line off right here. Right here.
I should do it in pencil.
Yeah. Maybe it's gonna work. Yeah, I know. It's from 1.
Miss, so what do you mean explaining? Like, in my own words, like,
I mean,
what it's asking me?
right. So what is this asking?
What is the area from 1 to 7?
33 for all of it?
There's 4 things that I want to hear. It's the area bounded by 4 things. What do you mean?
What's 13 times 4? Can we use your calculator?
The x-axis,
The graph.
the graph from x equals 1 to x equals 7, or the vertical lines x equals 2.
Oh, we did.
But I want to hear all 4 of those, and the answer is not 34. If you need your calculator for the computations, that's just fine.
4 plus 2 is 6, right? So that's 3.
What's 26 plus 8?
I do have options. You're going to go for 1.
34?
Okay, check.
Okay.
What do you mean? She probably doesn't know where to reach her number. This looks like
You did all of this? In that little time?
In order to be a trapezoid, you need to have
How are you so paranoid?
Are you shooting at us?
I got 34.
I got 30.
It's not 34.
Is it 33?
Show me where are you going from?
Oh.
From where?
The zero.
From 1 to 7. Oh. It's 1 to 7, I'm 0 to 7. Okay.
There you go. Most popular wrong answer, 34.
7.
Showing you one. Okay. So it's 33. I got it.
Sorry, then you want me to get back?
So you're gonna have to chop that. I agree. You also have to work two. So then what about the 4 pi divided by 4?
Yeah, it's just pi.
You could argue it's a trapezoid. You could also argue that it's a trapezoid with the bases. And then 6, 7.
I'm worried about doing it.
Oh, I have another.
Right, you can look at it.
What's the no, he said.
Explain the meaning.
Bounded by the X.
Dang, some of it.
He ain't teach us no sentence.
He said explain the meaning.
Do we have to write a sentence?
We don't know how to explain the meaning in a So
Well, you
from
could go
1
with
to
what I
7.
told you it means.
Yeah, but you said you gave us like the
The components. So
No, I gave you like the sentence.
Oh, we know the radius.
bounded
What does it mean?
Yeah, we know the radius.
on the X axis.
Oh, the area bounded by the x-axis, the graph of f of x, the line.
I didn't just give you these.
33.
Right.
Oh.
Oh, that's what that was.
Oh, the notation and oh.
Gotta go.
I didn't even know what that was.
Gotta go cry. Gotta go cry.
C pi.
No,
What he said the first time.
it is not pi. There
But we
is-
divide it by 4.
Yeah.
Or like, no, like me.
Pi is squared and the radius is 2.
Pi r squared, the radius is 2.
It was 33, right?
Yeah.
Divide by 4.
And you are gonna divide by 4 because it's only a fourth of the 2.
Yeah.
But that's not
By
pi.
the X axis
4 pi?
of the graph of every X.
The x-axis.
Oh.
Negative pi.
I care greatly about.
So under
X equals C.
even though under axis negative.
He has index cards.
Okay, this is gonna be a negative.
Oh yeah, this right here.
Because everything.
See?
So they're gonna end up being.
It's just 10.
It bothers me that it's just 10. Like, can it just be like 10?
That's what I said. I asked him and he was like, no.
Yeah. So how are you gonna give it a
But
unit?
it's still over.
No, you think you just write units. Alright. 7, 9. So 7, 9 would be negative.
Is it 6 minus 2 pi?
It's negative.
Oh, I see. So negative 6 plus 2 pi.
It would be pi.
It's pi. It's negative pi.
Would you destroy it?
Wait, let me figure it out.
R squared. The radius is clearly 2. It's just pi.
Negative pi.
Negative pi.
Whoa, so like what if half of it is above and half of it is below?
Then it's a 0.
Subtract.
I don't know, man.
We use 33.
What's positive plus negative?
0, okay, what's K?
It depends on the numbers.
Depends on it. You trying to be a smart.
No, dude, I mean, you just said half of it is on top, half of it is on bottom.
No.
I mean, half of it is positive.
Bye, Jose.
I really have to go to.
There's a dual right there. If it's an actual
No, but I want to finish it.
why am I smacking my lips?
Oh my god. Oh my god.
6 plus -4 pi.
Oh my god.
What's 6 plus -4?
So how did you?
What did he say when it goes the opposite direction? It's just negative? It's
Yeah.
13 to 7 now.
Oh yeah, it's in the opposite direction anyway.
And it would have been this, but this is 21.
Wait. For the triangle, did you get 6 for the area? Yeah. 6, right? Plus 4 pi.
Yeah. 6 minus 2 pi. 6 minus 2 pi.
It's 4 pi. Oh yeah, there's 2 pi.
So that starts at 13, that's negative.
Wait, but like, and then you just make that negative? Because if it's going in the reverse direction, didn't you say it's just negative anyways? Or like, do we add it as positives first?
It's
and
negative
then-
6 minus 2 pi. So it would be a negative number.
Negative 6 plus pi.
No.
Negative 6 minus pi.
2 pi.
I found it.
Negative 6 minus 2 pi. This is negative.
Oh no.
But then this also turns negative. I mean, it's already negative, so it turns positive.
This
So it's
little
negative
part
6 plus 2 pi. Did you say that? No, that's what Did you say negative 6 minus 2 pi? No, you said negative 6 minus 2 pi.
It does start from 0. This is when you take the bottom.
It's negative. They're gonna add together. That's negative.
But this is already
The
a
only
negative.
reason, look, think about this. The only reason this is negative is because it's going this way.
Okay, switch spaces.
You might be right, but I'm not sure.
This one?
I know what you mean because this is already negative, so making it negative again makes it positive. And so no. Dale.
I'm gonna trust my instinct.
Oh, I know what you're saying. But look, I've already defined all the boundaries for you. You can't change it. The problem that you're trying to solve. The problem that you're trying to solve is meant to be a challenge. Okay? What are the boundaries? Okay. So you have to start at x equals 0. What else are the boundaries? 22. But you also have to have the x-axis and the function. It sounds like you're shifting up the x-axis. You're like, oh, I'm going to go not with the x-axis. That is not where we are right now. There will come a day where that is what we're doing. Today would not be that day.
I hope that day never comes.
It will come.
I don't know what this is.
There's only one person who did a red card to not do drugs or whatever. Oh, I mean, but like.
That's probably Mr. Link.
Yeah, for Mr. Link, I'm like, whoa, that's impressive, bro. When it wants to be busy.
That's probably his.
I know Mr. Link's. Oh, is it? Go check.
Yeah.
The camera's stick. The camera.
Wait, so what'd you guys get for D?
So you're going from 30
Wait, what? Repeat that again.
What? Oh, I mean you have a pi in there, so I just have to belong. No, that's not the issue.
Don't
The
simplify
issue
it.
is that he brought up that like the bottom's already negative, so going backward would that make it positive?
Ask him.
What?
Yes.
All right, friends.
Con el cap.
Okay, I do not think everybody made it through all of the parts. There are some that I care more about than others. Hopefully on part B, everybody came out with 33. Life is good with 33. Okay, part C, the right answer? Pi or negative pi?
Negative pi.
Giselle, why negative pi?
Because under the x-axis.
Okay, because we're looking at the part of the graph that is underneath the x-axis, has to be a negative area. Agreed. Part D, the right answer, 2 pi minus 6. Or maybe you wrote it as -6 plus 2 pi. Okay. How many guys get to part E? Adriana made it to part E. Eunice, you made it to part E. Jonathan, you made it to part E. What do you think the answer to part E is, Jonathan? Jonathan? Hi, Jonathan Gonzalez. Not to be confused with the no other Jonathans that I teach this year. What'd you guys agree on for part E? 4.5, I agree. Yes, sir.
I have a question for D.
Yep.
Our given got -2 pi plus 6 because 6 is above the x-axis.
Look at your limits of integration. The question I'm asking you about, you're going from 13 to 7. Which means you're starting over here on the right, moving to the left.
Yeah, we forgot.
You gotta flip all of them. Did anybody get to part F?
Yeah.
A couple of folks last period made it to part F. What'd you guys get?
7.
7. We are not gonna have any conversation right now about part E and part F. I'm not worried about part E and part F. Okay? I wanna make sure that we're good with B, C, and D. It's just area. You're doing a bunch of area calculations, life is good. I do expect that all of these area formulas are comfortable for you and that you are ready to use them all of the time. I'll leave them up here. If you need to make flashcards, make some flashcards. But I would really like to make your lives really good by showing you how to do all of this on your calculator. Anyone interested? Calculator stuff is gonna be good. Now, where are my TI-84 people? Okay, Jasmine, hold on, I'll get to you. Everybody else, take out your calculator. Calculators need to be with you every single day for this unit. Know that any day you come without the calculator is the day that you are eligible for a demerit.
Dude, I want to get the black
Every demerit from homework.
We didn't calculate it?
Mine is such crap.
Alright, so to switch. Alright, so you've got your calculators out and ready. Jasmine, I will teach you what to do, but right now I'm going to focus on the TI Inspire crowd. So let's look at part G. Rombier, can you read part G using your best mathematical vocabulary?
Using your graphing calculator, find the exact value of integral 7 to 9 of f of x d of x. How does this compare to your answer from part C?
Okay, so we've already found this definite integral from 7 to 9 of f of x dx, and everybody knows what that answer is.
Negative pi.
Negative pi.
Negative pi. Here's how you're going to do it on the calculator. On the calculate screen, hit menu. And I'm sure you see something super helpful, something that makes you feel warm and fuzzy inside.
Calculus.
Calculus, option 4. More warm and fuzzy on the inside.
Numerical and
Integral.
Option 2, numerical integral. Just hit enter.
Lloyd.
Yes, indeed. I did not sneak into your homes last night and put this in there. It's been there all along. Trust your instincts here. Fill in the boxes.
I believe in the heart of it.
Wait, but they don't have a graph for
Okay, we'll get there. We're going from 7 to 9. You need to fill in the integrand. What's the function? Back to page 1. Back to page 1. We haven't used it yet. But if you look in that box, bottom far left, there's 1, 2, 3, 4, 5, 6 pieces.
Negative square root of 4 minus.
The negative square root of all this stuff, type it in.
Whoa.
Negative
You did this on first.
square root 4 minus x minus 9 squared. That's not a complete integrand yet.
No, it isn't.
You've got to tell me what you're integrating with respect to.
X.
You're integrating with respect to x. Hit enter.
Ooh, that negative pi. Oh.
What number is that?
Ooh, negative pi.
That was part G, negative 3.14159, blah, blah, blah.
Ooh, so smooth.
That's part G. Finish off part H. I need to teach Jasmine what to do with the TI-84. Somebody else has a TI-84.
It's not typing my X.
Okay. On your calculator screen. Math.
It's not typing my X.
And go arrow.
Tricks yourself.
Do you have yours on?
Huh?
Do you have your calculator?
I have no idea.
Yeah. So for you, it's mathematics. You know what I mean?
Should it be on reading or do we?
You are only ever going to be in radian mode in this class.
-3.
So for part H, find the definite integral from 7 to 8. My typers are retyping the whole problem. My lazy teenagers are the clever ones that remember how to copy and paste.
I don't.
Arrow up. Arrow up and highlight the thing that you've already typed. Hit enter. 7 to 8. Negative 1.228.
What error?
I'm going to arrow up again. I want the definite integral from 8 to 7. I am not going to waste my time and retype all of it. I'm just going to copy paste, and now I'm going to get positive 1.228. So arrow up.
Okay, no.
Now she
No. It's just
This is amazing.
Okay.
So like,
Take a moment to explain to your neighbor how, if you were not allowed to use your calculator for this part, how you'd get this answer. Don't tell me, tell your neighbor. If your calculator died mid-calculation, how would you get the second answer without the calculator?
You wouldn't do that.
What would you do if you didn't have the calculator? How would you get the answer to the second part? So how would we get the second one?
you just know it's the opposite line value because these.
Right, all I did is I changed my limits of integration, going from 7 to 8 or 8 to 6. That's the same answer. And then hit enter. Okay.
what did you expect?
You're good? Yeah. What's up?
I thought I had talked to you already. Like my, I remember when my hands were really ugly. For the dog, I had eczema, but I got really intense treatment. Beautiful. But now it's even bad.
I didn't think that. I didn't think that. You said it. I already said it.
All right. From here. Can I get you back here so you can drive? All right, friends, it's time to upgrade the skills one more time. One more upgrade of the skills coming.
Edgar's not ready.
From here, you're driving.
I got a license.
I'm going to erase all the good stuff. The idea that we're going to start with right now, we're going to play around with for the rest of this week. This is not the kind of idea that I think you are going to master in this next 10 minutes. We only have 11 minutes left.
Is this where it gets hard?
No, I don't think this is where it gets hard. This is where things get different. I hope for the most part everyone is feeling really comfortable right now. Right, so we get some geometry, we've got some area formulas. Too bad for the Jennifers. They'll get caught up, I'm sure. Okay, so here's the issue. George Riemann lived in the 1860s. You guys should have, it's on page 3.
Are you making up a story or is it real?
No, this is real. I don't make up stories. Okay. Okay, so George Riemann lived in the 1860s. George Riemann did not have a graphing calculator. He did not have Geometry Sketchpad, but he had an idea. What he wanted to be able to do was he wanted to be able to find area. He wanted to find area bounded by a curve, an x-axis, and 2 vertical lines. We know that we call this the definite integral. This is a definite integral. George Riemann was successful with this idea. Now I will tell you that this is the graph of y equals the square root of 64 minus x squared. And it might be a good idea for you to graph this on your calculator so you've got it to refer to. So y equals square root of 64 minus x squared. I will tell you that this is a semicircle centered at the origin, and the radius is 8. Okay. So get that graph on your calculator. And I bet, depending on your window, if you graph it, very few of you are going to see something that actually looks like a semicircle. You might have to adjust your window a little bit. Depending on your calculator, it might not actually look like a circle. It might look like an ellipse of some sort. So let me teach you a new zooming feature. Hit menu, and then zoom. Go to zoom square. Zoom square. Zoom square. So now, that thing that looked like maybe a top half of an ellipse, is everyone okay that this is a semicircle? Zoom square will make circles look like circles. It changes your windows for you. So, on your calculator real quick, please get me the area for the integral from 0 to 6. You know how to do this. Go get me the area from 0 to 6. Okay. What are we getting for the definite integral? What's that definite integral? Mariah, what are you getting for your answer?
I thought 43.01, is that right?
Okay, Giselle's offering up 43.0125. Eunice has got the same thing?
Yeah,
Okay. So the area is 43.0125, according to Giselle, according to the calculators. Look at the graph though. If I wanted to find the area from 0 to 6, here's 6. What's your strategy? What are you going to do? You're going to find the integral because it's 2015 and you have all this fabulous technology. But what if it's the 1860s and you want to find the area from 0 to 6? Anybody see any problem with this? Jasmine, what's the problem with this?
You have a curve.
You've got a curve. Now I'll tell you it's a semicircle. And circles are nice, right? Semicircles are nice. But I think we still have a problem. What's the problem? I will not tell you what the problem is. What's the problem? David, what's the problem?
We don't know the formula for a part of the area.
You don't know the formula for the part of an area. What if I was going from 0 all the way to 8? Would you know what to do? If we were going from 0 all the way over to 8, would we know what to do?
Mm-hmm.
Edgar, what would you do?
We'd find the area of the circle and then divide it by 4.
You take the area of a circle and divide by 4 because you're getting like a full quarter circle, but I've only got a portion of a circle. Marvin.
Do you use the rectangles multiplied by 2, leaving you with 4 equal parts?
Okay, so maybe you've been hanging out with George Riemann or some of the Calculus BC students who are like stealing my thunder. Here's what George Riemann's idea was. George Riemann said, if I can't, George Riemann said, if I want to find this area, what I'm going to do is I'm going to approximate the area. So let's look at this first part. What's the method that I talked about in this first one?
Left endpoint method.
The left endpoint method. So I'm just going to abbreviate it as the LEM, and more about that. Left endpoint method, then he says 4 rectangles. 4 rectangles of equal width. What we're going to do is we're going to go from 0 to 6, and I want to use 4 rectangles of equal width. So if I'm going to go from 0 to 6, how wide is each rectangle going to be?
4.
Not 4. I'm going from 0 to 6 with 4 rectangles of equal width. Oh, so awkward. I'm going from 0 to 6. That's 6 spaces.
1.5.
They're going to be 1.5. I bet what you did is you probably did something, you said like 6 minus 0 divided by 4. Right, 6 is the total length. I need to get there using 4 rectangles of equal width, so this is 1.5. Some vocabulary I want to get in here. This is going to be my interval. I'm going to go from 0 to 6. I'm going to partition the interval. The word partition just means chop it up. I'm going to partition the interval so that I go from 0 to 6, and each rectangle has a width of 1.5. So my partitioning starts at 0 and ends at 1.5. That's going to be the base of the first rectangle. The next rectangle that has a width of 1.5 starts at 1.5. Where does it end?
3.
It's going to end over here at 3. The next rectangle starts at 3 and ends 4.5. The last rectangle starts at 4.5 and ends at 6. Did I make it all the way from 0 to 6? Then I've successfully partitioned my interval into 4 pieces that each have the same width. The left endpoint method, as the name implies, I'm going to make a rectangle using the left endpoint. So start at 0 and go up to the curve, go all the way up, and then make a rectangle by going over and come down. That's my first rectangle. Do it again for the second rectangle. I'm using the, which method? Wait, which method? Left. Start at the left, go up to the curve, go over, and come back down. There's your second one. Left endpoint method again. Now I'm at 3. Go up, go over, go down. Fourth rectangle. Up, over, down. What I'm doing is I'm coming up with the exact area. This is an estimate, right? This cannot be the exact area. Now, think about this before you actually say anything. Overestimate or an underestimate? Don't say it, don't say it. Think about it. Think about it for 5 seconds. If it's an overestimate, give me a thumbs up. If this is an underestimate, give me a thumbs down. If you have no idea whether it's overestimate or underestimate, thumb sideways. Will finding the area of rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4 give me an overestimate or an underestimate? Overestimate? Underestimate? No idea. Noemi, why is it going to be an overestimate?
Because the rectangles go over the curve.
The rectangles are going over the curve. They're capturing more area than I'm interested in. Is everybody okay? So let's do the approximation. Here's what the approximation is going to look like. The integral from 0 to 6 of f of x dx, I'm going to use the approximate symbol. I need to find area of 4 rectangles. How do I find the area of a rectangle? Length times width. So how, or base times height, how wide is the base? 1.5. How tall? 8. For this first rectangle, the first rectangle is easy. You can see that it has a height of 8. But rather than writing it as 8, I'm going to write it this way. It's 1.5 times f of 0. Stay with me just for a second. It's the y value on the function when x is equal to 0. That's the first rectangle. We're just going to get this set up. Second rectangle, how wide? 1.5. How tall? How did I determine the height on the second rectangle? It's the left endpoint method. So I use the left endpoint, which is 1.5, and it's whatever the y value is on the function. Don't estimate it. You're just going to say f of 1.5. That's the second rectangle. Third rectangle, how wide? 1.5, how tall? F of 3 plus, last one, how wide? 1.5, how tall?